Thank you very much. Hi, I'm Helen Biggs from the Satellite Science team in a research program of the Bureau of Meteorology. Together with Pallavi Govekar, we make up the Satellite SST team at the Bureau. As of July, Chris Griffin has moved to another role at the Bureau, so at the moment it's just the two of us. Today I will cover what a GHRSST formatted satellite SST products, although Jean-Francois I think has covered that quite nicely, how the Australian Bureau of Meteorology produces these products, and why we do this, and feedback from the GHRSST product users in Australia, and then some useful tools and some information for using GHRSST products. Progress it. Okay, sorry, just trying to progress the slides. There. Okay, so I probably don't need to go over this because I think Jean-Francois has covered this. What is the GDS? So I'll save some time by skipping over it. But the Bureau started to use GDS version 1.7 for our level 4 SST products in 2006. Then from 2010, we used the GHRSST GDS version 2.0 for our level 2 and level 3 products. Then from 2019, we used it for level 4. So currently all our products for satellite SST are in the GHRSST GDS 2.0 format. We have not yet adopted the GDS 2.1 format because I was not aware of it till just before the meeting and I haven't read the manual yet. So we'll have a think about it though, whether we should upgrade our latest products to that particular format. So what are the IMOS GHRSST products? So through the IMOS project funding, the Bureau of Meteorology provides a range of high resolution level 2 geolocated products. Level 3 L3U single swath or seen gridded products. L3C are multiple swath and or seen from a single sensor and gridded. L3S, which are multiple infrared sensors and gridded, or level 4, which are multiple sensors from infrared or microwave, and they are sort of optimally interpolated to produce a gap-free product. Note that all the level 3 products that we produce are on the same consistent 0.022 degree lat by 0.02 degree long grid, which helps our users. We provide these SST products at 2 different depths. The skin, which is at approximately 10 micron depth, and which is sensitive to diurnal warming, and then the foundation SST, which is equivalent to several meters depth and which is not affected by diurnal warming. Okay, so we provide 39 real-time and reprocessed GHRSST products. So I think we provide about a quarter of what Jean-Francois mentioned. It's a bit embarrassing, actually. And all of these products in different flavours, depths, levels, sort of temporal durations, etc., are all available on the National Computational Infrastructure Computer, which is a supercomputer based in Canberra, Australia. And any student or scientist in Australia can, in fact, anywhere in the world, can apply to have an account on this computer, and they can then have direct access to the products from within the computer, or they can go to the thread server, which is a public thread server, and they can just download the products. So we make them very public, and they are also available on a subset of them available on the Australian Ocean Data Network. If you haven't gone to that portal and you're interested in any Australian ocean in situ or satellite data, check it out. There's an awful lot of data there. It's just a little hard to navigate, but I can help you find stuff if you need any help. Anyway, there's the list of products, as I said, and they are available on a range of levels, level 2, level 3, level 4, durations for, ranging from 1 hour to 1 month, and depth, skin or foundation. So it can be very confusing, and I apologise, we got a bit carried away with producing different products. Anyway, all the bureaus, IMOST, GHRSST level 2 and level 3 products follow GHRSST specifications, as I said, GDS 2.0, with useful information per pixel. We do actually provide a guide online for what each of the variables represent, and I can point you to that web page if you're interested. Shown here are just a selection of variables per pixel for the 7th of October 2013 from one nighttime HRPT AVHR composite from multiple InPost satellites, and that's an L3S product. Each GHRSST format L2P product includes a quality level for each SST pixel. In the case of L2P products derived from infrared radiometer data, the quality level, or QL, of the data is based on an estimate of degree of cloudiness or other forms of atmospheric interference, such as from dust or kind of aerosol smoke. So this is how in the GDS manual, I copied it from there. So this is what we are meant to follow, but not every producer does. So QL equals 0 is no data, QL equals 1 is bad data because it's either close to land or there's rain or something, or it's outside of the valid range for temperature. QL equals 2 is the worst quality data that you can actually plot or use, but it will probably be cloudy. So we don't recommend that someone use that data, but they can look at it if they so wish. Quality level 3 is the lowest quality data that one would probably want to plot, but it's still not the quality that you want if you want to ingest it into an ocean model, say, or into or to use for validation. Quality level 4 is generally okay. It's acceptable quality. It probably won't be cloudy. Quality level 5 is the best quality, and it's what we generally use for validation purposes. Each GHRSST producer of data applies their own cloud detection methods, which can vary quite a lot. For Bureau, IMOS, GHRSST, L2P products, we use 2 different cloud detection methods. We started off back in 2007, I think, with the, well, no, earlier actually, back in the 1990s, I think, with the CSIRO CleverX Cloud Mask method, and that's based on a threshold method. It's fairly, you know, it's been around a long time, let's say, where the quality level is determined by computing the distance of each pixel in kilometres to identified cloud. So in our case, for the sort of HRPT AVHR some L2P files, quality level 1 pixel is 1 to 2 kilometres from detected cloud. QL equals 2 would be 2 to 3 kilometres, etc. And QL5 is at least 5 kilometres from cloud. If you want to know the details, just go to the manual, the document written by Chris Griffin at the link there. Now, for the HEMERI 8 and 9 SST products that are being produced at the Bureau by Pallavi Govekar here, we use the ISRO-SST Climate Change Initiative Code from University of Reading, and that is a Bayesian cloud clearing method, which is documented in Chris Merchant's 2019 paper in Scientific Data, but also Owen Embury promises us that he's actually currently writing a paper, which when published will be the most up-to-date method, and we use their most up-to-date code now. So if you want to know more, just download Pallavi's presentation from session 2. So now for sensor-specific error statistics, what are they? Well, every producer of satellite of GRST products, they have their own method. It'd be nice to harmonise them perhaps, but we have our own method, which is based on an empirical model based on matchups with Boy SST data. It's documented in the Chris Griffin's technical report, which the link again is there. We use a rolling 1-month window adjusted every 5 days, and a 6-dimensional regression empirical model based on time of day, satellite zenith angle, quality level, longitude, latitude, and age of an SST value. Least squares regression to highly sort of correlated components. And the SSES bias and standard deviation are calculated for every single pixel. And the same method is applied to the geostationary satellite data and the polar orbiting satellite data at the Bureau. So now, as Pallavi might have touched on in the last session, SSES are not only useful for users to know the uncertainty in observations, but they can also be used to develop downstream merged multi-sensor SST products, such as the ones that we produce at the Bureau, like the multi-sensor L3S composites. And we really are very interested in how different agencies produce their SSES values and quality levels, because we need to put them into our system so that we can merge them correctly. So we use a number of different satellite SST products, level 2 and level 3, from agencies, not just the Bureau, from OCSAF. IFREMER provides the FRAC-AVHRR L2P data, and we composite that to 2-kilometre L3U files, and we get from NOAA Nesta Star the VIAS L3U products from NPP and NOAA 20 satellites, and hopefully soon from NOAA 21. And we have produced IMOS 2-kilometre multi-sensor L3S products from for 2012 to the present. So to merge data from the different satellites, the L3 USSTs are modified such that the modified quality level is redefined as the minimum of the original quality level in the L3U file, and an integer quality value, that is QS, calculated using the bias, SSES bias, and SSES standard deviation. Now, I won't go into these details because this is not exactly my work, but it's all documented in Pallavi's paper that was published in a remote sensing journal last year, 2022. So I suggest you go there for the details. Okay, so why does the Bureau produce GRST format products? We've been doing this for a long time. It's a lot of effort, but what's in it for us? So the Bureau applications like reef temp coral bleaching, image shown here on the right, and our operational daily SST analyses, L4 products for NWP models. We require SST and we require the bias and the quality level. We need to know the quality of each SST value going into our systems, and the consistent GHRSST format with uncertainties and quality flags and metadata does encourage broad user uptake and better science too. Yeah, we've been funded to do this for 15 years and we've just got the contracts for another 4 years. So we've got funding out to 2027, and getting funding is difficult, as everybody knows. We get the funding because most scientists and students in Australia, they use our IMOS GHRSST products. So obviously then we must be doing something right. And also it enables sort of international distribution via JPL PODAC portal, NCI's GHRSST Data Archive, which was started by Ken Casey, and now the GHRSST Data Catalogue, which, and I'll talk about those advantages in the next slide. So here is, yes, they are in the GHRSST catalogue. I did check prior to the meeting. There they are, so they do exist. That is just 4 of our products, but there are more in the catalogue. So we have L3C, L3S and L4 products now in the GHRSST catalogue, which is nice, so people can find them. And also Ramsar and Gamsar GDS2 L4 files are provided in near real time on the PODAC portal, and that's had significant benefits for us because that's where a lot of people go to download L4 products for papers, and it means that our products have been included in papers and intercompared with other L4 products, which I think is wonderful. Having the Gamsar SST analysis in GDS 2.0 L4 format and available in near real time from PODAC allows it to be used with other L4 global daily products to form the GHRSST multi-product ensemble, which is a median of those 11 L4 products that you can't read there, but they're in the slide and on the website. So currently I think it's 11, but it tends to vary anyway. And at the Met Office, they have validation plots daily in near real time where they compare each L4 product against the GIMPI, which is nice to have as a quick look, a check of the quality of the product, and also against Argo SST. So all this helps the data producer. And the NOAA NESTA STAR, like SST Quality Monitor web tool, produced by Sasha Ignatov's team at NOAA NESTA STAR, is particularly of value to data producers and to users because it allows one to use a range of different plots in near real time to check the quality of the L4 products. I find it extremely useful. I check this at least weekly. It is really helpful because we don't do this at the Bureau because we don't have the staff full time. We're a very, very small team. So I'm so grateful that NOAA STAR does this work. It's of high value to us. And you can see there some plots from the 29th of September of Gamsar L4 minus 4 other L4 products and some other time series or latitude plots there. There's a range of plots. You can play around with it. It's quite interesting. Okay, apart from spatial coverage and accuracy of SST products, it is useful to be able to assess an L3S or L4 product's feature resolution. And NOAA NESTA STAR has something called the AXPO, a regional monitor for SST ARMS web tool. For those of you who are doing the training workshop, after lunch, I noticed that that's going to be covered as well. So that's really handy. Unfortunately, it's only got a few ocean regions included. You'd have to talk very nicely to Sasha to have a domain around India included. But at the moment, they are mainly around the US, Europe and Australia. But there's one off the northwest shelf of Australia, and all I've done is I've plotted the Bureau's nighttime, one-day night multi-sensor L3S product for the 9th of September this year. I've compared it with the NOAA STARS nighttime PM, so that's the VIIRS L3S product on the same day. And the NOAA Geopolar Blend L4, so that's Andy Harris's and Eileen Maturi's L4 product that ingests no in situ data and no microwave data, just geostationary data and polar orbiting infrared data. And the Bureau's RAMSA daily SST analysis, that's my product, which ingests in situ data, infrared data and microwave data. JPL-MER there, which has got MODIS and AVHRR and in situ data from memory. No VIIRS yet, is that right, Ed? No VIIRS, yep. And Ostia L4 SST, which ingests in situ SST, some geostationary satellite SST, VIIRS, AVHRR, a microwave. So they have different inputs and sometimes they look slightly different, but it's a good way to check the quality of your product. Okay, so why do people in Australia use GHRSST format products? The IMOS GHRSST products are very easily and freely accessed, which means they are more widely used if people can find them and they're free from the as I said, Australian Ocean Data Network with the link there and NCI. Common GHRSST format aids operational ingestion in 2 operational models and analyses. At the Bureau, we use only GHRSST L2P and L3U files for all operational systems. So ocean models and SST analyses and SST analyses then go into our NWP and seasonal prediction. So, so it's very important to us. And we generally, although not always, subtract the SSES bias from each SST because we found that that does make it more accurate SST. So we've tested that though. And also the fact that all the IMOS GHRSST level 3 products are on the same 0.02 degree by 0.02 degree grid. Users like that because then they are more easy to visualize and to compare. And quick look maps are available from AODN and IMOS Ocean Current, and people love going to IMOS Ocean Current just to have a quick look. So this is, oh yes, so this is an example of a screenshot of the page, the IMOS sort of Ocean Current web tool page. This is where most of the users of SST products in Australia, this is where they go first. It's just really easy to use. They are fixed maps, but they can see in situ data, kind of SST, they can see where the gliders were, where the ships were, where the drifting buoys were, overlaid on maps of satellite data, and it's widely used. It's very, very popular. And it's got chlorophyll A, it's got winds, it's got all sorts of other data as well, and ocean currents. So it's sort of a one-stop shop for quick looks of what's going on in the ocean. Okay, oh yeah, and shown there was just a percentile map. That's based on, so that's a percentile map based on IMOS one-day night multi-sensor L3S data subtracted from the stars with the stars climatology, dated climatology. So this is my second last slide, the chair, sorry. I won't go through all these links, but I put these links here because I think they are really, really useful to users. So I wanted to put them on one slide so you can download my slides and then explore them. But the ones that I would like to note in particular, I mentioned in the last session, actually, promoting the January 2023 instruction to users of the set of GRIS products. That was a document that I helped the GRIS project office to produce, and Sandra Castro also helped us. And it's just a very short document that provides a bit of guidance and links and documents to people who want to use GRIS products. And also, as I gave a plug to my free online chapter, which is part of a really nice book for students that's free on applications of ocean satellite data. So this book, if you, I didn't put the exact link there, but you can find that in the documents. I highly recommend it. It's free, and it was written by Australian scientists who were experts in their field about satellite ocean data, specifically for users of satellite ocean data over the Australian region, but it might also apply to people in India too. Especially if they're global products. But anyway, so I'm just putting a plug for that because that provides guidance to users of not just the Bureau's IMOS satellite SST products, but global products. Now, this is my last slide. So the Bureau of Meteorology, through IMOS funding, produces 31 and growing years of 39 high-resolution GRIS-compliant products useful for monitoring all sorts of things like marine heat waves, coastal upwelling, coral heat stress, and climate trends over kind of Australasian waters. Our products are mostly just over the Australian domain and the Southern Ocean domain because that's where we are. You can find them at those links. If you would like more information on our products, I have a number of printouts of the Bureau SST fact sheet, which I've been pushing at people all week. I still have some left over, so come and see me after this session. And you can email us at grist@bom.gov.au. Now, I'd just like to say a big thank you to the GRIS science team. These Australian high-quality satellite SST products would not have been possible without the amazingly generous help from the GRIS science team. Shown here is when they came to Australia, which was 2007. And wow, that was a while ago now. But yeah, we are still meeting and still helping each other. Thank you.